welcome back to The Explainer. Today, we're diving into a seemingly mundane component that is, believe it or not, an absolute make or break safety decision. You know, when you're designing or supplying materials for a massive industrial project, it is so incredibly easy to get completely consumed by the big ticket items. I mean, we naturally focus on the heavy machinery, the structural steel framing, those multi-million-dollar power generators. But today, we're actually going to look away from all those glamorous macro components and focus on the arteries of these buildings, the cable systems. And more specifically, we are looking at the humble cable tray cover. It sounds almost too simple, right? Like it's just a piece of metal sitting over some wires. But as we unpack the engineering data today, you're going to see exactly how this single, frequently overlooked choice literally dictates the lifespan, the efficiency, and the ultimate safety of an entire facility.
So I want to kick things off with a question, because the answer completely flips how we normally think about industrial safety and risk management. Picture this. You've got miles and miles of expensive, highly conductive cabling running through the ceilings, weaving inside the walls, hidden right beneath the floors of a bustling facility. What is the silent threat to all of that critical infrastructure? Like, what actively reduces its lifespan and creates serious safety hazards right under our noses? Usually when we do risk assessments, we're looking for these massive, dramatic threats, right? We prep for sudden power surges, extreme weather, catastrophic mechanical failures. But the data shows us a totally different reality. The real danger to these multi-million-dollar networks is often quiet, it's constant, and it is entirely self-inflicted by one seemingly minor design choice made long before the building ever even opened. Yep, the answer is the wrong cable tray cover. Think of it kind of like putting on a heavy, fully zipped winter parka and then trying to run a marathon in the middle of July. When you choose a cover that doesn't match the specific environment, you are putting a literal lid on a ticking time bomb. All that heat generated by the active electrical current, it gets trapped inside the tray with absolutely nowhere to go. And because of that, the vital insulation around those active cables just begins to bake. The materials degrade way faster than their rated lifespan, they get brittle, they get compromised, and eventually, the whole system fails. It's really a sobering example of how a simple oversight on a cheap, tiny component can cascade into a massive, highly dangerous facility failure. You're essentially suffocating the building's nervous system. And this perfectly illustrates the high-stakes balancing act that engineers are facing every single day. You are juggling three core considerations all at once, and dropping even one of them leads to failure. First up, you have physical protection. I mean, the fundamental job here is shielding these sensitive cables from falling debris, thick dust, moisture, or even just an accidental bump from heavy equipment. But then comes the second, and honestly, often conflicting piece of the puzzle, heat management. Active cables generate a ton of thermal energy, and as we just talked about, trapping it is incredibly dangerous. Finally, there's maintenance accessibility. A heavy, completely sealed vault is fantastic for physical protection, sure, but it is an absolute nightmare if a technician needs to quickly get in there and inspect a fault line. So, balancing these three variables, keeping the bad stuff out, letting the heat out, and letting the human workers in, is really the defining challenge here.
Okay, so how do we actually navigate that tricky trade-off in the real world? Well, you have to match your physical shield exactly to your specific environmental extremes. Just look at the stark difference between plain, which are entirely solid covers, and ventilated covers. If your project is outdoors where it's constantly getting pounded by rain, or maybe it's in a heavily dusty manufacturing plant, a solid plain cover is exactly what you need. It gives you that uninterrupted, solid physical barrier. But if you take that exact same solid cover and install it in a high-temperature facility where ambient heat is already pushing the system to its limits, that is a disaster waiting to happen. In that scenario, ventilated covers become absolutely crucial just to let that dangerous heat escape. It's a highly precise matching game, and getting the context wrong can literally destroy the project.
And that heat problem brings us to a vital engineering concept, ampacity derating reduction factors. Now, I know that is a mouthful of a term, but it's incredibly important to understand if you want to grasp the real financial and operational impact here. Simply put, ampacity is just the maximum electrical current a cable can safely carry. When you restrict ventilation by slapping a solid cover over a highly active cable tray, the ambient temperature inside just skyrockets. And because of this trapped heat, the cables literally cannot carry as much current safely. Think of it like a computer processor intentionally throttling its own speed so it doesn't melt down, right? Engineers have to mathematically, intentionally reduce the allowed current carrying capacity of that network. If they don't calculate this derating perfectly, the whole system overheats. But if they derate too much, well, now you're paying top dollar for heavy, expensive cables but only getting a fraction of their actual performance. But look, aside from all the complex thermodynamics, we absolutely cannot forget the human element.
Facility managers need rapid access to these cables. When things go sideways or even just when mandatory routine inspections pop up, maintenance teams do not have the luxury of time. They need to get into the tray, find the electrical issue, and secure the system immediately to avoid crazy expensive facility downtime. If a cover is overly complex, or it's exceptionally heavy, or worse, requires specialized tools just to take a quick peek inside, you are adding hours to simple maintenance schedules, and that friction drastically inflates labor costs over the life of the building. The perfect design really strikes a harmony. It locks down tight against the elements, but it yields quickly and intuitively for the professionals whose job it is to keep the facility running smoothly. To see how this complex puzzle actually gets solved, we can look at the comprehensive manufacturing scope of a company like Xinma. They really represent the deep, specialized expertise you need to clear these engineering hurdles. Top-tier manufacturers aren't just stamping out basic metal lids and calling it a day. No, they are engineering full holistic systems. We're talking about sophisticated busway networks, seismic bracing to ensure everything stays structurally stable during an earthquake, and fully integrated smart solutions. By looking at the problem from a wide lens, systems like this make sure that the physical protection, the crucial heat dissipation, and that quick maintenance access we talked about all work seamlessly together in one unified design. It's basically the ultimate case study in how integrated engineering solves multifaceted problems. And because the physical and financial stakes are so incredibly high, these advanced systems have to be deployed under super strict, industry-specific global standards. For instance, in modern data centers where uptime is literally everything and managing heat is a 24/7 battle, systems adhere to the rigorous IEC 61537 standard. But switch over to something like rail transit, which is a highly dynamic, heavy vibration environment where a loose component can be fatal, and you're relying on strict NEMA VE1 compliance. Heavy industrial plants operate under BSEN 50085, while your standard complex commercial buildings use GB 31251 to keep everyday occupants safe. This immense variety really highlights that no matter the industry, whether you're managing server heat or protecting transit wiring from shock, rigorous adherence to these specific codes is the absolute rock-solid foundation of operational safety.
So what does this all mean for us? Well, we've seen today how something as seemingly basic as a simple metal cover dictates thermal dynamics, current carrying capacity, and the ultimate safety of a multi-million-dollar facility. It is a powerful reminder that in complex engineering and massive procurement projects, there is truly no such thing as an insignificant detail. Every single component, right down to the lid on a wire tray, determines the survival and efficiency of the entire system. So the next time you walk through a commercial space or you're reviewing a project blueprint, I want you to ask yourself, is the infrastructure up there actively protecting the building, or is it silently destroying it? Thanks so much for joining me for this explainer. Keep learning, keep questioning the small details, and I'll see you next time.